Welcome to Brain Vision.
Hi friends, this is the problem based on transfer of heat by conduction method. Here it is given a cylindrical conductor having inner radius A and outer radius B. This is A and this is B. So inner radius is given A and outer radius is B, and having coefficient of thermal conductivity K. In the first part we have to find the expression for thermal current, and thermal current is defined as dq upon dt. If there is a thin spherical shell of radius a of radius r and thickness dr, then for temperature difference of dt between inner and outer surface, rate of flow of heat dq upon dt will be equal to k 4 pi r square dt upon dr. This is called the thermal current. Rate of flow of heat is called the thermal current. So from here, for cylindrical surface, radius varies from A to B. So we can say h dr upon r square is equal to 4 pi k dt. Integrating both the side for the time limit having the value, temperature limit is T1 to T2 and radius A to B, because inner surface having the temperature T1 and outer surface T2. Integration of 1 upon h is constant. Integration of 1 upon r square will be minus 1 upon r for the limit A to B. 4 pi k is constant. Integration of dt is T, and for the limit T1 to T2. So on substituting the limit and simplifying, rate of flow of heat or thermal current, you will get 4 pi k A into B T2 minus T1 upon A. We say equation 2. This is the answer of part A. Now in part B, we have to calculate temperature as a function of radial distance r. So if we consider the flow of heat between A to R, it will be H is equal to K 4 pi R square dt upon dr. So it can be written as H dr upon R square 4 pi K dt. Now integrated, initial temperature T1 to Tr and A to R, integrated and substitute the limit. So from equation in above equation you may write 4 pi k r minus a upon ar tr minus t1, dividing equation 3 and 2, you will get tr to be equal to t2 minus t1 into r minus a over b minus a into b upon r plus t1. So this is the required answer for part B. C part. In actual practice for cylinder, the area will change. Area will be 2 pi rn. So equation 1 can be written as h is equal to k 2 pi rl into dt. So h is equal to dr upon r 2 pi l into k dt. Integrating for the limit t1 to t2 and a to b, you will get h into ln of r 2 pi k into l t. So from here h you will get 2 pi k l t2 minus t1 ln of b upon a. D part. Similarly, to calculate temperature as a function of r for cylindrical surface, h will be equal to 2 pi k l. Method will be the same as we have discussed above upon ln of r upon a. So from equation 4 and 5, divide the equation 5 by 4. You will get temperature as a function of r to be T2 minus T1 ln of r upon a upon ln of b upon a plus T1. For very thin cylindrical conductor, b minus a which is approaching to 0. So equation 2 can be written as 4 pi a square k T2 minus T1 upon L So fourth equation becomes 2 pi kl T2 minus T1 upon ln of A plus L upon A. If we apply the condition L is to be very small, so it could be written as KL T2 minus T1 divided by L upon A. So 2 pi KAL T2 minus T1 upon L1. That's all.